Hey everybody, it's Jason at JacFab. It's been a while. I'm working on something interesting today, so I thought I'd record something. I'm gonna have to keep it kind of short because the GoPro's only got one bar on the battery. I don't have a charge cable. So you may be looking at this mess of crap trying to figure out what we're doing. Well, this is a stock LTG 2.0 water pump. And here at JacFab, we are going to be working on a new smart electric water pump. We've got all the guts per se. We need to figure out the smart end of it, but anyway, it's an idea and it will work, and this is the initial testing phase. Now basically what I'm hoping to achieve here is create a sealed system so this water pump will pump, and hopefully you can pump it back uphill into this bucket, and the gravity will hopefully help feed the suction side. But once I get this thing primed and actually pumping and stuff, we got this flow meter. Boom. We're going to put that in line on the output side and see how many gallons per minute that this stock water pump can do at a known RPM. That way we have something to base our electric version testing off of. So this is all done. You didn't get to see all this fun stuff. I've been messing around for about 2 hours here, but we'll throw a bucket of water in the bucket and try and make this thing spin some water, and we'll see what happens. Oh, that looks good. Kind of leaning to the side there. Okay. Well, that went much better than I thought it would. All right. So, I guess let's half-assedly prime the system. Okay. I would consider that pretty primed. So that's a good sign. Now I've got a Lovejoy coupler that I've kind of put on the end of the pump. I've already removed the factory pulley. So I'm gonna go get a drill and we'll run this with the drill first to make sure it pumps. And then I'll use the Lovejoy on the electric motor. That's a DC motor, so I'll have to rig up a power supply. But anyway, rig that up, set the RPM on the motor, install the flow meter, and then we know basically we're going to use our electric motor to drive the stock water pump at a known RPM, see how many gallons a minute it flows, and that gives us a starting point. Now go figure, I keep turning the camera off because the battery's about to die, but I wish it still would have been recording, because as soon as I walk away to go get this dicom and the drill, this hose falls out, and now I've got 5 gallons of water on the floor. That's awesome. So anyway, I got this blue dicom. It's not food coloring. I'm gonna dump it in the water so maybe you can see the magic happen as we spin the drill and verify that just a little dab will do you. Verify that this thing is pumping. So there you go. All right, so I'm gonna try and stand out of the way here, but it's gonna be a little difficult. So I got way too much crap going on. So anyway, this is my drill, Lovejoy water pump. We're gonna spin this and watch this line as it starts to turn blue, and this is my return line back to the bucket. There's that blue. Alright, and now it's going to come out the return line, I'm hoping. Turning blue, look at that. Alright. Now it looks like we're possibly getting some cavitation in the pump there. There's a lot of bubbles coming out, so that's very interesting to see. But look at that nice blue water now. Boy, alright. So anyway, now that we know this thing's pumping in its sealed system, I can go ahead and rig up the flow meter, and we'll get the electric motor on here, get it tuned, and then set the RPM, and then we'll see something scientific. Alright, well, I've been playing with this for, I don't know, an hour or two now, and to say nothing else, it's been very educational. This is the motor that we've been planning to run, and I know based on the voltage that we can supply in a car that's DC. I'm not sure where the camera is pointing, but this is my DC power supply. Based on the voltage that we can supply in the car to this DC motor, and you know, we're just running a stock impeller right now. I'm gonna make a new impeller that's gonna pump even more water at a lower RPM than this stock setup. But this particular motor that we were hoping to run cannot run even the stock impeller at the RPM that we can get out of the car. So yeah, I mean, it'll run for about 30 seconds, and then it shuts down because it's overpowered, using too much torque. Just can't push this water. And so, you know, this setup that I have here is pretty crude, but if you think about it, say, you know, your engine's here, the head's up here, right? And so this is your head, which, you know, there's coolant up there, which gravity feeds down, so that was my thought here. And then, you know, the shit comes down into the radiator and pumps up through the radiator, and so you're pumping up. So this is the best that I can simulate an actual working system out of a car, you know, short of spending hundreds and hundreds of dollars. But it's I can't say that's mind-boggling, but I'm very surprised from playing with this that this can't run the stock water pump at the RPM that I know we can get with the voltage out of the car without shutting down. So basically, I can run this at about 1/3 less of the RPMs that I know we can get in the car based off the 12-volt system. Now, and so there's apparently, you know, I've never really thought about this, but apparently it takes a lot more power to move water in a system similar to in a car than I had ever thought. So it's very interesting. You know, as of right now, I've pumped about 105 gallons or so through this 5-gallon bucket, just going back and forth, which is also just mind-blowing that I've pumped 100 gallons just screwing with this. And it's amazing. It's mind-blowing. But anyway, so basically what I can do today is I can tell you what this pump runs in gallons per minute at a third less power, not power, but RPMs less than this is capable of. But it just can't do it because apparently to move that water requires more power than this motor, which is commonly found, you know, in all kinds of things, is capable of without shutting down. So very interesting. Hello. So basically I've got my iPhone stopwatch here that I'm gonna run this thing for a minute at 2000 RPMs, which is roughly, let me get my calculator out here. So basically when your car is at 1420 RPMs, that's what your stock water pump is spinning, 2000 RPMs. So this will tell us what the stock water pump puts out at 2000 RPMs for in gallons per minute, I guess. So I'll go ahead and hook up the motor and I'll focus the camera on the meter and we'll just see what it runs at for a minute. Okay, so we're currently at 0 gallons and 1.5 tenths of a gallon. Stopwatch is at 0. So I've set this to a nice slow ramp up. I'm gonna plug it in. We're gonna hit start. Okay, go. One gallon, 12 seconds. Two gallons, 20 seconds. We're at 3 gallons, 29 seconds, 30 seconds. 4 gallons, 38 seconds. 5 gallons, 48 seconds. At 6 gallons, 55 seconds. And we're gonna hit stop and pull the motor off. So 6.5, 7 gallons in a minute at 2000 RPMs. Well, I can't truly say that this was a 100% success. We got some data. Basically, when your water pump is turning at 2000 RPMs, it's pumping about 6 to 7 gallons per minute through your engine when your engine is turning approximately 1400 and some odd RPMs. So we got some data. It's not the data I wanted because this motor is incapable of running at full speed because it requires more power to pump said water at full speed of this motor than the motor can do. So the motor keeps shutting down, so I had back the power down. But anyway, that's good. I mean, it wasn't a waste of a day. I got this thing pumping, it's working, so that's cool. Basically, our next step is we're gonna buy a bigger motor and we'll run it again and get the data with that we need at full speed out of the bigger motor and go from there. But anyway, that's, you know, that's the first step. That's how this stuff happens. You test, you play. This was the cheapest motor that I could get, and that's why we chose it. Not that it's poor quality, but it was the highest power motor at the cheapest price that I could get. So we're going to spend a little more. We'll buy a more powerful motor that will be able to pump this water at the speed that I know that the voltage in the car can supply. So you know, it's very interesting. Obviously that there's a lot more draw on the engine to pump this water than I think there is, which is neat because that means when this finally does work, that's gonna free up all this extra horsepower, and we haven't even dove into the smart features yet. So the smart features is what's gonna sell this thing. Thanks for watching JacFab'in Saturday.